Hello everyone. Let's finish the last part of the stoichiometry calculations, mass to mass conversion. So you can see I kept the same examples like I used for mole to mass or mass to mole conversions so that you can make a connection. So in this last part of the stoichiometry calculation, so something in the grams will be given to you and something you need to find in grams. So it could be reactants or product each way. So let's jump to the example. Example first. So how many grams of nitric oxide is produced if we use 12 grams of oxygen with excess of ammonia? So this access has some meaning which I will explain to you all in the next video as a limiting reagent or access reagent. It's very important. So let's focus here first. Mass to mass conversion. So in the chemical reaction, we use 4 moles of ammonia with 5 moles of oxygen. We form 6 moles of water and 4 moles of nitric oxide. But in the questions, our focus is nitric oxide and oxygen. Forget about the others. So same steps. What do you know? Conversion factor. What do you need to find? Like you can see, I have already made the table to save my time. Okay, so what do you know? What do you know means what value is given to you in the question. So what do you know? In this case, 12 grams of oxygen are given to me. That will go here. So 12 grams of oxygen here. Okay, what do you want to find? So how many grams of nitric oxide? It means I need nitric oxide in terms of grams. So grams nitric oxide. It means conversion factor will circle around oxygen and nitric oxide. But first, if you need nitric oxide in conversion factor zone, first I need to change grams into moles so that I can use my molar ratio from the balance equation. So how I'm gonna convert these grams into moles, same concept. 1 mole of anything in terms of grams is equal to its molar mass. So you can see in the question, molar mass I have already written, oxygen is 32 grams. So kids usually are confused. They think oxygen means O, but if you ever see that the word we use oxygen, not formula. So oxygen means their natural state of existence, that is O2, not O. So if we are using oxygen atom, so atom should be mentioned in the question. So yes, so 1 mole of oxygen is equal to 32 grams. Here we go, 32 grams. So 32 grams. So you can see same units cancels. So now I have oxygen in terms of moles. So you can write the formula here. Sorry about the handwriting. Okay, so now I need nitric oxide on state. So for that I have to use their molar ratio. So how many moles of oxygen we have used in the balance equation? 5. And how many moles of nitric oxide we have produced in the balance equation? That is 4. So I want to cancel the oxygen. I will write 5 moles of oxygen at the bottom. Here we go. And 4 moles of nitric oxide at the top. I will write 4 moles of oxygen. Oh, sorry, nitric oxide. Nitric oxide. Here we go. Moles oxygen cancelled. So now I have nitric oxide in terms of moles, but I need nitric oxide in terms of grams. So I'm going to change these moles into grams. Same concept. 1 mole of anything in terms of grams is equal to its molar mass. So 1 mole of nitric oxide is equal to, what is the molar mass? 30 grams of nitric oxide. 30 grams of nitric oxide. Here we go. Moles of nitric oxide cancelled. Now I have nitric oxide in terms of grams. So let's find the answer. So I will open the calculator. 12 times 4 times 30. Okay, divided by 32, divided by 5. I will still say use the Desmos calculator, but for normal calculation this calculator is fine. So we have answer 9 grams of nitric oxides. Here we go. This was your first example. Let's jump to the second example. Here, let's first read the question so that we can draw our 3 columns. How many grams of oxygen are produced when 24.5 grams of potassium chlorate, means KClO3, decomposes completely? So you can say this is a decomposition reaction. So molar mass of KClO3 is given to you, molar mass of oxygen is given to you. So it means you need to find the grams of oxygen, mass to mass conversion. So 24.5 grams of KClO3 is given to you. Grams to grams. So it's pretty clear. Here we go over 3 columns. In the first column, we'll use the different color. What do you know? What do you know? What do you know means the number or value of which formula is given to you. Third column. What do you need to find? What do you need to find? So it's pretty clear in the question. I want to find grams of oxygen. Conversion factor. So first column said KClO3 and third column said oxygen. So my conversion factor should be having oxygen and KClO3. So we are not using KCl. Conversion factor. Okay. What do you know? I know 24.5 grams of KClO3. Here we go. 25 grams of KClO3. What do you want to find? I need amount of oxygen, but in terms of grams. Grams oxygen. Here we go. So how will we get oxygen on stage? Only if we are using molar ratio. So it means this should be in moles. Only then you can use the molar ratio. But if you are using molar ratio first, it doesn't make sense. So be very careful when you're using the conversion factor. So I want to change gram KClO3 into moles. I will write 1 mole at the top. 1 mole of KClO3 at the top. Which is equal to its molar mass. It's given to you, or you can find 123 grams of KClO3. KClO3. Why I'm writing units? So that we know we are cancelling the same unit. That's the part of dimensional analysis. Be very careful. Same unit should be cancelled. If you're multiplying same unit, it means you're using the wrong conversion factor. Your whole stoichiometry will be wrong. In research, in the lab, whatever the calculations we are doing, so the other are actually based on dimensional analysis, and this is one small fraction of your research lab calculation too. So now KClO3 is in terms of moles. Now we can get oxygen on stage by using the molar ratio. Here we go. I want to cancel the moles of KClO3, so I will write the moles of KClO3 as a denominator. How many moles of KClO3 are given to you in the balance equation 2? You will write 2 moles of KClO3 at the bottom, means denominator KClO3. Here we go. How many moles of oxygen we have produced? 3. I will write 3 moles of oxygen at the top. Moles KClO3 out. Moles oxygen in. And now my oxygen is here. I just need to change moles into your grams. So same concept. 1 mole of any compound in terms of grams is its molar mass. That is equal to 32 grams of oxygen. Moles out, grams in. Let's check how much amount we have. We use 24.5 grams times 3 times 32 divided by 123 divided by 2. Here we go. 9.5 or 9.6. So we can round off 9.6, or you can write 10. So this was our second example. Let's jump to our last example for this third part of your stoichiometry calculations. So here, this is your, we are combining hydrogen with the oxygen and we are synthesizing water. So this is a synthesis reaction. So we have used 2 moles of hydrogen and 1 mole of oxygen and 2 moles of water are produced. Let's jump to the question. How many grams of water are produced? So this is my question. If 16 gram of oxygen reacts, so this is given to you with excess of hydrogen. I will explain this excess term in my next video. So it means 16 gram of oxygen, 2 grams of water. So it's pretty clear. Let's make our 3 columns. So in the first column, what do you know? What do you know? Once you understand the concept, maybe then you don't have to use these 3 columns, but if you're doing the first time, I will say you should use 3 columns. What do you need to find? What do you need to find? And then conversion factor. I hope now you know what should be in the conversion factor column. That will be your water and oxygen. Forget about the hydrogen. Here we go. What is given to you? 16 gram of oxygen. Okay. And what do you want to find? I want to find amount of water. You can see I haven't given you molar mass of oxygen, hydrogen and water because I'm assuming few things should be known to you if you are in advanced stage. So yes, if you want water on state, first for that you need to use molar ratio. For that, oxygen should be in moles. So let's convert grams oxygen into mole. So I will write 1 mole of oxygen is equal to molar mass 32 grams of oxygen. Here we go. Grams out, moles in. Now we can use our molar ratio. So how many moles of oxygen we have used? 1 mole. Pretty easy. 1 mole of oxygen. Make sure if you're using molar ratio, your equation should be balanced. I don't think so for advanced kids. Every time your teacher will give you the balance equation, so you should know how to balance equation first. So yes, how many moles of water we have produced? 2 moles of water. 2 moles of water. Here we go. Mole oxygen out. Now we have water, but in terms of moles, I want to change moles into grams. I will use molar mass of water. 1 mole of water is equal to 18 grams of water. You can watch my other video for how to find the molar mass. So moles water out, we have grams water in. So let's do the calculation. All right. Okay, 1 second. Okay, so 16 grams times 2 times 18 divided by 32, and this is equal to 18. Yeah, pretty clear. 32 grams of water. So we have produced 32 grams of water. So use 16 grams. So molar ratio is 1 to 2. Means you use 1 mole and you produce double the amount of water. So it's clear 16 grams of oxygen gave you 32 grams of water. Alright, I hope it clear your concepts or doubts for how to do the stoichiometry calculations. In the next video, I will show you how to find the limiting reagent and excess reagent. There are a few parts, especially for the advanced kids or AP level kids. And after that, I will show you the pH calculations. Alright, stay tuned. Thank you. Have a good day.